Hi, and welcome to a video on how to use indirect measurement using similar triangles. Today we are going to learn 3 different methods for solving these kinds of problems, or more succinctly, we're going to do 3 different types of problems. And the first thing you need to make sure you do anytime you're doing any kind of a problem is make sure you understand the problem, and in these problems we're going to definitely sketch diagrams. The second thing we're going to do, because we have similar triangles and similar triangles are proportional, we're going to set up a proportion after we determine the triangles are similar. And remember, when we determine if triangles are similar, we need to use AA similarity, SSS similarity, or SSS similarity. So those are our 3 strategies for making sure that we can actually set up a proportion. And then the last thing we're going to do is we're going to solve the proportion and answer the question. All right, so let's take a look at our first problem here. Our first problem is let me give myself a little bit more space here. Our first problem is this. At a certain time of day, a 6-foot tall man casts a 4-foot long shadow. At the same time of day, a tree casts a 20-foot long shadow. How tall is that tree? Okay, so I'm going to sketch a picture of what's going on here. I have a 6-foot tall man, and we're going to assume that he is forming a right angle with the ground, and this shadow that he's casting is 4 foot long. Now, when the sun is shining near two things that are relatively close together, that angle is going to be approximately the same for the man and for the tree, right? So that sun is going to hit this tree at the same angle that it hit the man. So these angles are going to be congruent. And the tree is also, we're going to assume that's forming a right angle with the ground because it's going to be growing vertically up. So if this tree casts a 22-foot long shadow, we can calculate the height of the tree, x, using that triangle. So if we look at these two triangles, we can see that they have this angle at which the sun is casting the shadow is congruent in both triangles, and both triangles have a right angle. So in these two triangles we have angle, angle, congruence. So the two triangles are congruent, so we can set up a proportion. So the proportion that we're going to set up, and there are a lot of ways to do this, I'm going to say 6 is to x, so I'm going to compare these vertical lengths. 6 is to x as 4 is to 22. And when I use cross products to solve that, I'm going to have 22 times 6 equals 4 times x. I'm going to divide both sides by 4. I'm just going to punch this in my calculator at the very end, and I'm going to get x, or the height of the tree, is approximately, in this problem, it is going to be 33 feet tall. Okay, so for this problem, I have drawn my picture, verified that the two triangles are in fact similar, set up a proportion, and then solved my problem. Okay, let's look at the next problem. And the next problem we have is Tassie is driving through a mountain pass. Let me give myself a little more space here, and then we will go through our steps with this problem. Okay, driving through the mountains, Tassie has to go up and over a high mountain pass. The road has a constant incline for 8.5 miles to the top of the pass. Okay, so we have a constant incline for 8.5 miles. Tassie notices from a road sign that in the first mile she ascends 750 vertical feet. How many feet does she ascend in total when she gets to the top of the pass? So let's first draw a picture. So here's kind of our baseline. Here's the mountain pass. She's ascending vertically, right? Well, she's ascending on this road which is sloping, and we want to know this vertical change by the time she gets to the end of this 8.5 mile road. Now, we know after 1 mile, right? So we're going to say that this is just 1 mile here from this to here. We know after 1 mile she has ascended 750 vertical feet. So we want to know how many vertical feet she'll ascend over the total 8.5 miles. Now, if you look at these two triangles, we've got two nested triangles. We have the smaller triangle, right? That is 1 mile to 750 feet. And then we have the larger triangle that is the entire 8.5 miles in x feet. Now, if you look at these two triangles, they share this angle, so these angles are going to be congruent in both triangles. And when you're measuring vertical feet, you're measuring at a perpendicular. Remember, because when we measure distance, we always measure along the perpendicular if we're measuring the distance to a line. So these two are going to be perpendicular. So again, here we have angle-angle similarity. So we know these two triangles are similar, so we can set up our proportion. So for this problem, our proportion is going to be, and again, there are many ways to set up a correct proportion. I'm going to set up 1 mile is to 8.5 miles as 750 vertical feet is to x vertical feet. And now I can say x is equal to 750 times 8.5. And when I put that into my calculator, I'm going to get that x is approximately 6,375 feet. And if you want to divide that by 5,280 feet per mile, you can figure out how many vertical miles that is, and that would be approximately 1.207 vertical miles. Okay, so again, we're using our similar triangles to set up and solve this problem. Let's do one last problem. This one is a mirror problem, and this is a common type of problem that you might see because when you have a mirror, the angle of reflection, okay, so for example, let's say you have a mirror on the ground, the angle at which light or a line of sight goes into the mirror is going to be exactly the same as the angle that that light or line of vision exits. So you're going to get congruence with those two angles. So let's read this problem. A 5-foot tall woman is 4 feet away from a mirror on the ground. She sees the top of a building reflected in the mirror. If the mirror is 35 feet away from the base of the building, then how tall is the building? Okay, so let's go ahead and draw our woman. Our woman is, we're going to say she's right here, and she is 5 feet tall, and this is our mirror right here, and she is 4 feet away from this mirror. Okay? And when a person stands with the ground, we're going to assume that they're standing perpendicular to the ground, and that the ground is flat in this case. And I think in this problem, we are told the ground is completely flat from where the woman is standing to the base of the building. So that's good. The ground is flat. Now, the other thing that we know is that this mirror is 35 feet, right, away from the building. So I'm going to put a 35 feet here, and right, this mirror is getting the top of the building. The woman is able to see the top of the building in her line of sight. And again, buildings are built, right? If they're built properly, they're perpendicular to the ground. So if you look at these two triangles, right, I have a right angle, and I have that angle of reflection going in is the same as the angle of reflection going out. So again, I have angle-angle similarity. We know these two triangles are similar. So we can use these two similar triangles to figure out the height of the building, which I've labeled x. So to set up my proportion here, I'm going to say that 5 is to x, our vertical measurements. 5 is to x as 4 is to 35. My pen is getting a little wonky there. Okay, there we go. Now, we're going to solve this proportion. So I'm going to do 5 times 35 is equal to 4 times x. I'm going to divide by 4, and I'm just going to put this in my calculator and see what I get. And I get x to be approximately 44 feet, or 43, right? 43.75 feet. But I believe in this problem we are asked to round to the nearest whole foot. So let's follow directions. X is approximately 44 feet, so our building is approximately 44 feet tall for this problem. Let me make that a little bit nicer. Okay, so now if you look, let's go back and just kind of compare these three problems. All three of these problems, we made a sketch, we determined similarity, we wrote a proportion, and we solved it. And if you look at all these, the sketches are somewhat different, right? In the mountain pass problem, that was a triangle nested in a triangle. For the mirror problem, right, we have two triangles. One's a dilation of the other, but also kind of a reflection and a dilation simultaneously. And then this first one we did, the two triangles, one was kind of a dilation and a translation of the other. So these are the three most common types of problems that you are going to see when you're using indirect measurement and similar triangles. So please remember these three steps, right? Be organized. This is going to help you work quickly and accurately through the problem as long as you understand the problem first. Sketches are always helpful. Second, set up a proportion. And third, solve the problem and answer the question. I hope this video helped you understand how to do this. Thank you for watching.